Imagine something so powerful it can swallow stars whole. Something so dark it erases time, space, and everything in between. You can't see it, you can't touch it, but it's out there. Right now, black holes are drifting through our galaxy, invisible, undetectable, except by what disappears into it. So, what exactly is a black hole? And why are scientists obsessed with them? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. Imagine a place where the pull of gravity is so intense it creates a one-way door. Once you cross that door, there's no coming back. We call that door the event horizon. It's the invisible boundary surrounding the black hole. Cross it and you vanish from the universe as we know it. At the very heart of the black hole lies the singularity, a point of infinite density where space and time as we understand them break down. All the known laws of physics are pushed to their limits here. It's a mystery wrapped inside an enigma. Most black holes are born when massive stars die. Stars shine by burning fuel, mainly hydrogen, in their cores. When a star, many times the mass of our sun, runs out of fuel, the outward pressure that holds it up disappears. Gravity takes over, crushing the core in a spectacular implosion known as gravitational collapse. The outer layers explode in a supernova, one of the most energetic events in the universe, sending shockwaves and heavy elements across space. If the core left behind is massive enough, it compresses into a black hole, a region where gravity wins completely. Black holes come in different sizes. Stellar mass black holes, which form from the collapse of individual stars, typically have masses between 5 and 30 times that of our Sun. Then there are supermassive black holes, monsters millions or even billions of times heavier than our Sun, lurking at the centers of galaxies, including our own Milky Way. There's also a theoretical middle class called intermediate mass black holes, which may be the building blocks between stellar and supermassive black holes, though we're still searching for solid evidence. Some scientists even theorize about primordial black holes, tiny ones formed just after the Big Bang, but those remain speculative. You can't see a black hole directly because no light escapes it, but we can detect their presence by watching how they affect their surroundings. One way is by observing stars orbiting invisible objects with enormous gravity. For decades, astronomers have tracked stars orbiting an unseen mass at the center of the Milky Way, now known as Sagittarius A, confirming it as a supermassive black hole. We also watch how matter falls into black holes. As gas, dust, or even whole stars spiral inward, they heat up and emit intense X-rays before vanishing beyond the event horizon. Space telescopes help us catch these signals. In 2015, scientists made an incredible breakthrough. The LIGO observatory detected gravitational waves, ripples in space-time, produced by the merger of two black holes over 1 billion light-years away. This discovery opened a brand new way to study the universe, allowing us to hear events that were previously invisible. Since then, detectors like Virgo and Kagra have joined the hunt, capturing collisions of black holes and neutron stars, revealing their masses, spins, and even hints about their environments. In April 2019, a historic achievement was announced: the first ever image of a black hole's shadow. Captured by the Event Horizon Telescope, a global network of radio telescopes, this image showed the glowing ring of hot gas around the supermassive black hole in galaxy M87, 53 million light-years away. This glowing halo wasn't the black hole itself, since it's invisible, but the bright edge of the event horizon, where light gets bent and trapped. It was a cosmic milestone that turned science fiction into scientific fact. There are some famous black holes worth knowing about. Cygnus X1 was the first strong black hole candidate discovered in the 1960s. It's part of a binary system where a black hole pulls matter from a companion star. Sagittarius A star is our galaxy's supermassive black hole, about 4 million times the Sun's mass, hiding 26,000 light-years away in the constellation Sagittarius. The M87 black hole, which is located at the center of the elliptical galaxy Messier 87, is approximately 53 to 60 million light-years away from Earth. Specifically, M87 is located in the Virgo cluster and the constellation Virgo. When black holes consume matter, it's not a quiet dinner. In 2020, astronomers observed a star being shredded by a black hole 215 million light-years away, a phenomenon called a tidal disruption event. The star's remains formed a spiraling disk of glowing gas around the black hole, emitting powerful bursts of energy. Such events help us understand how black holes grow and affect their environments. What if you fell into a black hole? At first, you might feel normal, but as you approach the event horizon, gravity's pull grows uneven, stronger at your feet than your head, stretching you like spaghetti. This is spaghettification. Crossing the event horizon means you are lost to the outside universe forever. What happens next? It's a mystery. You might be crushed at the singularity, or maybe, as some quantum theories suggest, information could survive or escape through wormholes. These ideas inspire science fiction but remain unproven science. Black holes aren't just cosmic monsters, they are key players in galaxy evolution. Supermassive black holes influence star formation, regulate the flow of gas, and shape the structure of galaxies. Studying them helps test Einstein's theory of general relativity under extreme gravity, revealing new physics. Black holes might also be windows into dark matter, the mysterious substance making up most of the universe's mass. Time behaves strangely near black holes. If you orbited one safely for a few hours, years might pass in the rest of the universe, a phenomenon called time dilation. Stephen Hawking showed that black holes aren't completely black. They emit faint Hawking radiation due to quantum effects near the event horizon. Over unimaginably long timescales, black holes could evaporate, changing our ideas about the fate of the universe. NASA's James Webb Space Telescope, launched in 2021, is already reshaping our understanding of black holes and their early formation in the young universe. With its powerful infrared eyes, it peers through cosmic dust, revealing how black holes grow and influence their surroundings. Future missions promise even deeper insights. Black holes are much common than we previously believed. There could be over 100 million black holes in our galaxy alone. Black holes are so dense that a teaspoon of its material would weigh billions of tons. Some spin near the speed of light, dragging space-time in a vortex called frame dragging. Black holes challenge our understanding of reality, pushing us to rethink time, space, and the nature of information. They are not just destructive forces, they are gateways to new knowledge. They force us to ask the biggest questions. What is the nature of time? What happens to information? Can something truly disappear? These aren't just theoretical musings, they're the frontier of modern science. So the next time you look up at the stars, remember, somewhere out there a black hole is waiting, silent, invisible, powerful beyond comprehension, and possibly the key to understanding the very fabric of our universe. This is AstroTheatis, exploring deep space, discoveries, and the limitless possibilities of the cosmos. If you enjoyed this journey into the unknown, then you will like the recommended video above. Stay curious and keep looking up.